Hello, this presentation is about flowcharting, one of the many ways to model a process. Computer process flowcharting has been around since about 1947, when four symbols were adopted to use in this particular model. These symbols are an oval to represent beginning and ending, a rectangle which indicates an inner process, a diamond which represents a decision point in the process, and a parallelogram which indicates input and output. There are other symbols available, but for our purposes, we'll use these four. A couple of guidelines for creating flowcharts. Place an arrowed line between the elements. Makes it easy to follow the process. Don't cross the lines if at all possible. Makes it more difficult to follow the process. Decision elements represent a Boolean response, either yes or no, true or false. And when you use a decision element, make sure you label the lines coming off of the decision. Lastly, there is no one perfect model for any process. Today I'm going to describe how to model a programming process using a flowchart. There are three basic structures used in programming: sequence, selection, and iteration. Often you'll see a combination of all three in one flowchart. So let's use this scenario. A customer decides they want to buy some cable and want an estimate from the company. The cost per foot of cable is 87 cents. To model this process, we'll use a sequence structure. Just as it sounds, a sequence structure is just that, steps done in sequence. Take a look at the first flowchart. We have a start, there's an input for the number of feet from the customer, a calculation of total cost, and then an output of that total cost, and the process ends. Now the scenario changes to having different prices for different lengths of cable. So for that change, we'll use a selection structure. Take a look at the second flowchart. As you can see, it starts off the same as the first one. Once the user inputs the lengths, however, we get to a decision element. Is the number of feet less than 100? If so, then the price is 87 cents per foot. If the length is more than 100 feet, then the customer gets a discount and the price is only 80 cents a foot. Remember, a decision element is Boolean, yes or no, or true or false. Once we know the cost, we calculate the total cost, output that, and end the process. Notice how the lines labeled coming off the decision element? Now the scenario changes again to reflect the fact that we may have more than one customer requesting an estimate. To model that, we'll use iteration. Take a look at the third flowchart. It's the same as the second until after the total cost output. Then a decision element. Is there another customer? If not, the process ends. If there is, then the process goes back up to the input where the next customer will input the number of feet needed. This process, this loop, is continued until the answer to is there another customer is no. Lastly, using the same scenario as we did for the third flowchart, this time we know how many customers are in the queue. To manage this, we're going to need a sentinel value, which is a condition of terminating that loop. At what value does the process start? How many customers in the queue? For this type of iteration, think a counted loop, it's the developer's choice whether to count up or to count down. For this example, we're going to count down, starting with the customer count of 3. The sentinel value shown is that the number of customers must be greater than 1. Once that's not true, the loop is ended, and in this case, the process stops. So, when the first customer is finished, the question is asked, is customer number greater than 1? If yes, and it is, then we subtract 1 from customer number and go back up to the top to get input and calculate costs for the second customer. At that point, the customer number is 2. Is that greater than 1? If yes, and it is, then we subtract 1 from customer number and go back up to get the input and calculate costs for the third customer. At the end of that process, the customer number is 1. Is that greater than 1? Since it's not, true, then the loop is ended, and in this case, the process ends. So that's basic flowcharting.